And as for the contents, I'm not 100% sure, but my screen frozen again. Yeah, my screen is frozen. Let me stop share and reshare. Okay, seems like more people are joining our discussion right now. Okay, as for the lecture contents, I'm not sure if I'm 100% correct, but like you guys can prove if I'm wrong. I was told that homework 37 is not, like lecture 37 is not in the scope of final, but lecture 36/37 is in the scope. So basically, we don't cover anything about lecture 37, and for that should be 38. But for 38, the homework is now required for submission, but the content is covered in the final, and there is a homework for 38. And as for quizzes, yeah, and as for discussion, this is the last discussion of this semester. But like I might hold office hour during the regular discussion time. I'm not 100% sure yet. I need to like Professor Sankova will like mention more announcements during the weekly meeting for GSI this weekend. So yeah, I guess if I get any updates regarding logistically, I will make announcement on B course. Okay, and then for quizzes, so there's still like some students from my section 1 who haven't respond to the course evaluation yet, but there's enough students for my section 2 who respond to the quiz. So guys, I will make that happen. So for the quiz correction, so like I will grade your quiz 13. Like your grade for quiz 13 will be up to date. And so like you can choose one quiz out of the 13 quiz, like whichever quiz you want. And I have already created a tab for submission on Gradescope. It's called quiz correction. You can like submit whichever quiz you want for quiz correction, and the deadline is Sunday 11. So maybe like the early deadline is Sunday 11th. Not 11th. It's Sunday 9 p.m. I guess. So that's the early deadline. It was due in like 3 or 4 days. Yeah. So the reason of that is because so this quiz correction is something I did for my sections. Like other JSI are not doing that. So on Sunday's meeting of JSI meeting, professor might let us to turn in your final score, the final score, all the scores combined without finals, and then like it will be kept fixed somewhere in her system. So I'm afraid that will happen. So I mean, if you can submit your quiz correction as soon as possible, that's definitely will make sure that you will receive on like if you submit it after during RR week, whether you can get the points or not. So I'm writing an early deadline. If I get an update that we are not like turning in your final score on Sunday, I might make an announcement to like extend the deadline for this quiz correction. But I mean, it wouldn't take too long. It would probably take 1 hour to do your quiz correction. So do it as soon as possible. And another thing is that for quiz correction, the content itself, there's one thing I want to mention as different from other quiz correction is that you have to write which quiz and which problem. On the first page of submission. So basically you are submitting on Quizscope and you will have a lot of pages. And on the first page, I want to say only the quiz number and the problem numbers. So I can like do that for you. Or fail to label the pages, or like fail to write the quiz number and problem number may result in insufficient quiz correction, and you may not get points back. And again, I want to mention that the requirements for quiz correction, there are 3 requirements. The first one is you have to provide a thorough and complete solution, like correct solution. This should be more rigor and thorough than the solution I provided. I mean, it will be like at least as thorough as what I have. And then for the second step, you need to like write why you are doing wrong, and analyze reasons you did wrong. And for the third step, and that's the most important step, you need to generalize your own problem solving strategy for general problems in this tab or in this topic. So these are the rules for a good is the screen frozen? Okay. Yeah. So that's the guideline for quiz correction. And if possible, please highlight this part and this part for me. Like you can write for the quiz correction, you can write like a big, like after your first page on like numbers, and you can on the second page you can write a big one, writing a solution. And for 2, you might want to explain the reason you do wrong, and write a big 3 on the corner to say your generalized problem solving strategy. And if you do that completely, you will get about 50% to 60% of your grade back. Like that's a good quiz correction. If you didn't, it will be like anywhere between under 50% grade back. depending on how good your quiz question is. And if you only include the correct solution, you're probably not getting your score back because I already provided the solution to you. So instead of just like copy and paste, the most important thing I want to say is part 2 and part 3. But you still need to write part 1 to be like considered as a good quiz question. Yes, so that's it. For logistic about quiz. Okay, we talk about quiz, we talk about discussion, we talk about lecture, we talk about homework. Yeah, I think that's it for my announcement. That's a lot out of here. And for the lecture for the discussion recording, I recently found that I can embed the YouTube video and the lecture note in the B course as an assignment. So it's pretty fancy, and you can like check it out. And also like for you are doing a quiz question, you can look back on what I wrote here during the record in the record, so that it makes sure that you follow each step. Yeah, so for today's discussion, since you have not looked at the discussion for Friday yet, so we will not cover too much about that. And also like for Wednesday's lecture is not covered in the final exam, so I guess I will not also like cover too much about that. So I think we will still like focus on the chi-square test. And so for today, I want you to look at our discussion worksheet 26 first. So we'll cover questions from both 26 and 27. So for now, let's look at worksheet 26, section 1, problem 4. And update your progress with me. So our plan is we will finish worksheet 26 and then we will work on worksheet 27. I wrote it on the screen, worksheet 26, section 1, number 4. So that's the problem of the P plant. Yeah, if you finish problem 4, update with me, and you can work on the other section. And if you finish the other section, you can work on worksheet 27. Yeah. I haven't received any response yet, so if everyone haven't finished the first one, like no one are finishing the first one. All right. Okay. I guess I'll just wait for more time. Once you find the R value, you calculate the degree of freedom, and then you look up on a chi-square table or an online applet. Okay, if you finish, please work on problem 1 in section 2. Yeah, I haven't got like enough response to talk about the solution of problem 4. Oh, and actually, I just want to share the reason why I want to do a quiz correction for you. It's because like for the quiz I made, it might be like a little harder than other GSIs made. I don't know, like our quiz score is slightly lower than our expected quiz score. So but like the quiz score is like curved in a whole class scope. I mean, it would be like better if we can like get our score better. And also one phenomenon is that our our like median every time is greater than mean. So that means like more people are getting good scores. Well, like there are some students who are getting like very low scores. Like relatively to the mean and median. And the quiz question, if I get like percentage back, that means like for those who didn't do very well on a quiz can get more points back. But the median itself wasn't changed so much. So like we will not face a situation when like the median is too high. That will like affect curving down situation. But like we keep our median similarly, and in a way that we improve our mean drastically. So it's beneficial for everyone. So like I just personally think that's a really brilliant idea. Yeah. Like if you are curious, that's the reason why I want to do that. Kind of trick on the system. So like don't tell this to other people. Okay. Let me talk about this problem. All right. So remember, like for problem 4, we're working on a category test of goodness of fit. This is different from category test of independence. For goodness of fit, we want to look at all possible scenarios and list it in one column. So for this problem, the all possible outcomes are tall purple, tall white, short purple, and short white. So that's our outcomes. And after reading the problem, like remember the table is outcomes, observed value, expected value, and difference squared over expected value. So after we read the problem, you can fill out the observed frequency directly. So observed frequency in this problem was given 123 and 25 and 12, and with a total of 160. So you can fill out the first two columns immediately. And then what you do is like you look at the problem. The problem should give you some hints on how to calculate the expected value. So in this problem, the idea is that we were given that the ratio in a biological concept of these four outcomes are 9 to 3 to 3 to 1, which means that our expected value given 160 measurements should be follow this this ratio. So the first one would be 9/16, where the 16 comes from 9 plus 3 plus 3 plus 1 times, that's the probability in the system, and we just time it with 160 population like or samples, which we time it with the size, so probability times size, and 3/16 times or yeah 1/16 times 160. So then we handle the third column, which is expectation. We can calculate them directly. And then we want to calculate the difference square divided by the expectation. The difference square is the observed minus expected to the square divided by 90, which is the expected value. And then 23 minus and then 23 minus 30, which is expected value divided by 30. 25 minus 30 squared divided by 30, and 12 minus 10 squared divided by 10. So our statistic is defined to be the summation of the last column here. So if you calculate it out, it's roughly 3.98. And then we also need another statistic, which is the degree of freedom. And degree of freedom is in a chi-square test of goodness of fit is the number of possible outcomes minus 1. In this case, it's 4 minus 1 because we have 4 possible outcomes. So our degree of freedom is 3. And then we can like check a chi-square table with significance level with significance level 0.05 and degree of freedom 3. The table will give you the result that the critical value in this case is 7.81. But remember what this critical value means. So on a distribution, this means that at 7.81, that's the boundary of rejection zone. So everything on the right is the rejection zone. But our statistic is 3.98, which does not lie in the rejection zone. So we don't have enough evidence to reject our null hypothesis. All right. Please work on problem 1 in section 2 and problem 2 in section 2. I'll give you about 10 minutes on this problem. And for those who finish, please update your progress with me. Like I expect some of you to finish these problems already. All right, let's talk about this first problem. Since I haven't got too much of reply, so I guess we're not too familiar with tests for independence. So let me lead you through. I'll probably give you a little bit more time on problem 2 as well. I want you to do it by yourself. So for this problem, we are testing if the ice cream preference will affect your midterm performance or not. So we're doing a hypothesis testing. We're doing like a test for independence. Part A, what is the hypothesis test you're using? Our null hypothesis is that the ice cream flavor preference is independent with the midterm performance. And our alternative hypothesis is that this is not independent with the midterm preference. So that's part A. We set up the hypothesis and null hypothesis, and then we want to determine if what test we're using. So apparently we're using a chi-square test of independence because we're solving a problem. We're testing if our null hypothesis, which is something related to independence, is correct or not. And for part C, we're actually calculating the p-value. So we want to set up a table for that. I want to set up a table for that. So remember, for doing test of independence, we write the possible outcomes for one event on the left side and one possible outcomes for other event on the top. So there are two events. The first one is devel, like performance midterm, and it can be like well or not well. And another thing is another event is a flavor of ice cream. It can be either vanilla or chocolate. And we want to write our observed value and expected value on each column, observed and expected. And we want to write the total here. So after reading a problem, what you can fill out is all the observed value. So I'm just like now reading the problem and fill out the observed value. And what I can also fill it in is the total values. You can fill in all the total values. And how do you calculate the expected value? So the formula is for each expected value, you look at the corresponding total for in each row and each column. So for example, for this one would be 26. That is the row total, the column total, and then times 25, which is the row total, divided by 50. So that's the answer for expected value for this point, which is 13. Similarly, you can do it on all the other three. This one will be 26 times 25 over 50, which is also 13. This will be 24 times 25 over 50, which is 12. This one will be 24 times 25 over 50, which is 12 as well. And then we want to calculate the R statistic. The R statistic is defined to be the sum over outcomes of observed value minus expected value squared divided by the expected value. I just have no idea why my screen is frozen continuously, repetitively again and again. Yeah, so here we have our R statistic. And then we want to like calculate them all together. So the first one would be 15 minus 13. It's still not responding. This is so annoying. So the first one was 15 over 13 squared divided by 13. So because we're looking at this value and this value. And the second one will be 11 minus 13 squared over 13. So we're looking at this value and this value. So we do the same thing for the other two. And finally, we'll get a result of 1.28. And then we just like finish calculating the degree of freedom. We're specifically finished talking about R statistics. We need also calculate the degree of freedom. The degree of freedom is for the test of independence is the possible number of possible outcome for event A minus 1 times number of possible outcome for B minus 1. So in this case, there's only two possible outcomes for performance on midterm. It's either well or not well. And there's only two possible outcomes for ice cream preferences, either vanilla or chocolate. So that's also 2 minus 1. So our degree of freedom is just 1. So we plug in value of degree of freedom 1 and our statistic 1.28 to our online applet to check our p-value. So our p-value in this case is roughly 0.2579. But our significant level is 0.05. So our p-value is greater than our significant level. So we fail to reject. And another thing I want to highlight here is that for conclusion, you should always say reject null hypothesis or fail to reject null hypothesis. These are two possible conclusions. Null hypothesis is correct or null hypothesis is incorrect. This is not a conclusion because we are doing statistical tests. We can't give we're not proving the result. We can just reject our assumption or not. So specifically for this problem, the conclusion should be we don't have enough evidence to say that ice cream preference affects the performance on midterm. Instead of concluding that ice cream does not affect midterm preference. Like if you write ice cream does not affect midterm preference, that's a wrong conclusion. So that's something I want to highlight. Yeah, and I guess I'll give you some extra minutes on problem 2. And please update your progress with me. I haven't received too much of your response since last question. All right, let's talk about problem 2. So for problem 2, we want to see a relationship between colors of squirrels and the shape of their beak. So I'll just write we're doing color versus shape. So we're listing A possible outcomes, and this A possible outcomes can be categorized as 4 colors and 2 shapes. So our null hypothesis is there. So this is independent, and our alternative hypothesis not independent. So like I'm writing it for short, but like in your exam you should write as full sentence. The color and shape are independent. And then we want to because we're testing the independence, we're using a chi-square test of independence. And then we want to like make a table. So remember, for a table, we're listing like outcomes for event A. So this could be the color, this could be the shape, and for the shape, it can be either flat or curved. And we have like observed value and expected value. Observed value and expected value. And our color can be red or brown or black and white. So after reading the problem, we can fill out the observed value and the total value immediately. So our observed value are 10, 13, 11, 6. So like that's something the question has already provided us. And all we need to do here is to calculate the total. Here is 40, 60, 25, 20, 30, 25, and 100. So that's something we can write immediately after reading the problem. And then we want to calculate the expected value. The expected value, again, is we only look at the row and column for each expected value in the table. So for this one, only 25 and 40 are like 25 is the row total, and 40 is the column total, and we want to divide it by the entire total, which is 100. And similarly, I'm just like doing it for every else. 20 times 40 over 100, 30 times 40 over 100, 25 over 40 over 100. And for the second column, we're looking at the sum of the second column versus 25, which is the first row, over 100, 60 times 20 over 100, 60 times 30 over 100, 60 times 25 over 100. So the value here is 10, 10, 12, 8. This is 15, 15, 18, and 12. So remember, our statistic is the summation of observed value minus expected value squared divided by the observed value. In this case is 10 minus 10 squared over 10 plus 13 minus 8 squared over 8 plus 11 minus 12 squared over 12 plus 6 minus 10 squared over 10, and the other 4 on the second column. So together, at last you will get the result that is roughly 0.01. And then we want to calculate the degree of freedom because we already have our statistic. So remember, the degree of freedom is all possible number of possible outcomes for event 1 minus for event A minus 1 times the number of possible outcomes for event B minus 1. For event A, let's say it's the color. We have like 4 possible outcomes for the color. So that's 4 minus 1. And for event B, that's the shape. It can be either flat or curved. So that's 2 minus 1. So in total, the degree of freedom is 3. So we can plug in the degree of freedom and our statistic into our online applet, and we will get a p-value that is roughly 0.0458. So we know that this is less than 0.05, which is our significant level defined here in this problem. So we can draw a conclusion that we reject the null hypothesis. And we conclude that there is not independence between these two value. The online calculator, there's a link I sent last time, and I believe, like I forgot the link. It's in the statistical department. Yeah, maybe check out the discussion worksheet I sent on Bcourse. It is on it's on the discussion note, the discussion note I have on Bcourse. There's a discussion 26, and there's a discussion note. On that, I have handwritten the link. All right, so that's all for discussion worksheet 26. So let's move to 27. For 27, on section 1, the first problem we have already discussed. The second problem is what we want to do. So maybe like work on problem 2 and problem 3. The second section, the probability theory and the Hall-Head fallacy is something we will not cover. Like, I mean, obviously, probability theory is something we will cover in the final, but like the Hall-Head fallacy is something like we discussed in lecture 37, I guess. That's not like required, but you have to know the probability theory here. And for section 3, that's correlation of the line of the batch fit. That's something that we will discuss on tomorrow's lecture. So if you are interested, look at the solution for this full problem. I believe the solution rec is pretty clear. So if you have questions, feel free to ask me. For now, we will just like focus on problem 2 and 3. If I have time, I can like give you a short preview on the section 3. But for now, I'll work on problem 2 and 3. So problem 2 and 3 in worksheet 27, section 1. Let me see if I can find the link for you. It's on the B course for our own sections. There is an assignment called Discussion 26. Yeah, but I guess I found the link. It's stat.berkeley.edu/tutor.dark. HTML. So you go to that link and you click the chi-square distribution. All right, let's discuss this problem. So for this problem, that's similar to what we did before. So part A, we're asking the percent of applicants who are female. So we're basically do a simple division. The population of female divided by the total applicants, which is males plus female. That will give us the result, which is 34%. And then what percent of admitted students were female? So we want to calculate the admitted students. So we know that out of all the applicants, 35% of them are accepted, and we just need to divide it by over like the total applicants, which is the male accepted students and female accepted students, which is 44 times 8442. The male applicants, male accepted, and plus the female accepted. And what is the overall acceptance rate? We just need to use the overall, so that's like overall accepted students over total applicants. So that's the overall admission rate. So for overall accepted students, there are like the accepted male students and accepted female students divided by the total applicants, which is the number of male applicants plus female applicants, and this is roughly 41%. And then for part B, we want to test if there is bias in genders in terms of admission status. So our null hypothesis is the gender and admission are independent, whereas our alternative hypothesis is gender and admission are not independent. So for that, we need a chi-square test of independence to say if that's actually the truth. So we construct a table. So let's say admission status of one event. It can be either admit or denied. And gender is another event. It can be either male or female. And we want to look at the observed value versus expected value. And observed value versus expected value total. So we're given that we have 3738 observe like male students who are getting accepted, and there are 4704 that denied. And for female, there are 1494 students get accepted, and 2827 get denied. And we can calculate the total here. So the total for admitted is 3738 plus 1494, which is 5232. And denied is 4764 plus 2827, which is 7791. So the total is 8442 plus 4321. It's 12763. And again, we use our formula to calculate our expected value. In this case, this one is 8442 times 5232 over 12763. And this is 8442 times 7791 over 12763. 4321 times 5232 over 12763. 4321 times 7791 over 12763. I mean, the number is hard to calculate, but eventually you will calculate some number for this pool, and you're getting the R statistic of the summation of observed minus expected square over expected. Another shortcut specifically for this problem is that since we are given that the overall average acceptance rate are 41%, for the expected value, you can just directly calculate that as, for example, for male expected applicants, that will be 8442 times 41%, and for male denial, it will be 8442 times 59%. It will give you the roughly same value, but like again, I just want you to stick with the routine problem solving. So just follow the routine, even if the number is hard. I mean, you can still solve that. So we can get our R statistic, that's roughly 111. And our degree of freedom is possible to outcomes, male and female, 2 minus 1. And admission statistics, only 2 possibility, admitted or denied, that's also 2 minus 1. So degree of freedom is 1. So right now we can input this value and use the online applet to check the results. But 111 is actually overwhelmingly big for the applet. So we actually use a chi-square table in this case. The chi-square table for significance level 0.05 and degree of freedom 1 gives you 3.84. But like our R value is significantly larger than 3.84. So it falls in the rejection zone. And we will reject our null hypothesis. For problem 3, that's roughly that's like the Simpson's paradox. It's basically saying that even if like the acceptance rate for men in each department is lower than the acceptance rate for women, it's possible that the overall acceptance rate is greater because the number of applicants for males is much larger than females. So I wouldn't worry about that because it's not in the scope of our exam. So for now, I would like, by the end of the class, I would like you to do a poll. Yeah. So this poll is primarily, I would like you to read through what I wrote here. I will give you like my idea about like how to review this final. Like specifically, how do you review for the written problem, step 1, step 2, step 3, and how do you review for your multiple choice. I mean, it might be pretty helpful for you in terms of reviewing for finals. So do read it carefully. and this will be taken as section participation grade. If you finish, don't leave yet. I have something to say. Yeah, and also like for those who haven't done the course evaluation, if you are from section 1, please fill it out. Like like if you are from section 1, please fill out that, like my section 1 only have like 10 students. So each of you who respond to the course evaluation will increase the response rate by 10%. If you didn't do that, that will also like be decreased for 10%. So like respond to and the way you access that is in your email. You search like course evaluation. There will be a link for Max 10B, and you can go to that link, and there will be like JSI Zihao, and you can like evaluate me. At the very end, I just want to say thank you for everyone who attended my section and be in my section for the entire semester. Like all my students, I feel like you are really good students. You are like hardworking. You are eager to think, eager to learn. I just feel like very thankful for you to be in my section. This is like my first semester teaching this, actually teaching any class. But I do enjoy a lot teaching you. I feel like there's a lot of like interaction and engagement. I actually also learn a lot from you because you guys are always asking great questions. And then to answer your great questions, I have to like prepare well. I have to like understand all the concepts, like how like each concept is related to another concept, so I can give you the big structure and big picture. I know like even given the situation that we are like learning remotely kind of affects a lot. Originally, what I planned is that at the very last section, I will bring some snacks and bring some food and drinks together. Like we will just enjoy our last section, but apparently we're in remote learning, we can do that. So maybe like next semester, if we have a chance, I will like call out for everyone in both of my sections. Like we will like after the various are gone, we will like gather together, and I will bring some food and drinks, and we will just like talk about our experience in summer and talk about like fun facts and like just enjoy for some time like in next semester. And also I'm just an undergrad, I'm not graduate, so I will be on campus. So if you see me crossing the road, just say hi to me. Like instead of being like an instructor, I want to be more than a friend with you. And yeah, and if you have any questions, just feel free to ask me. Even if like the semester ends, you can always reach out through my email. And also like you can add my Facebook friend. If you just like search Zihao Zhao on Facebook, there will be a profile of me like holding an umbrella or something, and that's my profile. Like you can always add a friend with me. I mean like after this class, we're not like we're essentially we're just friends. Yeah, you can also add my LinkedIn. Yeah, I also have LinkedIn profile. Yeah, like I just feel very thankful for you guys to be here. Yeah, and I hope good luck on your finals. And feel free to ask me questions about like reviewing your finals. All right, and don't forget about the grade regrade the quiz correction. That will boost your score for a bit. So you're free to go. Good luck on your rest of the day. Thank you, everyone. All right, I'm gonna end the meeting.